So today we're going to cover our last technique or last way of solving a system of equations, and this method is called the elimination method. So when we want to use the elimination method, we need to get both equations into standard form. And what that means is it needs to be an ax plus by equals c. Really what's important here is that both equations have the x terms lined up, the y terms, and then the constant. Now, if you need to change either one or both equations, so that way when you combine the two equations together, in other words, add them together, one variable is going to cancel out. So what we're looking to do is make sure that either your x coefficients have the same number, but one positive, one negative, or the y's. It doesn't matter. You can choose. If you're given the system where it's already set to cancel, you're not going to need to change anything. Sometimes you won't have to change anything. Sometimes you'll have to change one of the equations, and then other times you may have to change both. Then after you cancel out and combine them, you get your first variable. Once you get that value of that variable, you plug it back in to either original equation and solve for the other variable. Now, just like yesterday, the substitution method, we have the two special cases. So if both variables cancel out and the statement that is left is false, then it's no solution. If the variables cancel out and you're left with a true statement, that's when it's all real numbers. So let's try and do 4 examples. So my first one, here is my system. Notice they're both in standard form. I have my x's lined up, my y's, and my constants. However, looking at it, I do not have the same number in front of my x's or the same number with an opposite sign in front of my y's. So I'm going to need to multiply and change one of the equations in order to get one of the variables to cancel. It doesn't matter which variable you choose to cancel. I'm going to go ahead and eliminate the x. And the way that I'm going to do that, and you could have chosen to eliminate y, is I'm going to take my second equation and I'm going to multiply it by a -2, which will then turn that second equation to have the same number but opposite sign as the first equation. So let me go ahead and write my second equation in here. I'm now going to distribute a -2 to the x, to the -y, and to the +9. Don't forget about that constant at the end. So -2x, -2 times -y becomes +2y, and then -2 times 9 gives me -18. I'm now going to take my other equation, the top one, and write it underneath because I need my x's and y's and my constants lined up. Now that I have the number in front of x to be same number but opposite signs, I'm going to add or combine my two equations together. Once I add -2x plus 2x, that cancels, and now that's left leaving me 0. And then 2y plus 3y gives me 5y, and -18 plus 13 gives me -5. Now I'm going to go ahead and divide both sides by +5, and I get y equals -1. I now take my newly found value of y, and I'm going to substitute it back in to one of the originals. It doesn't matter which one you plug it into. I always look for the equation where I think it's going to involve the least amount of work. I'm going to go ahead and plug it into the second one. My second equation was x minus y equals 9. What I'm doing is taking out just the letter y and replacing it with what y equals. So x minus is part of the equation that's there. Now I can put in my y value, which was -1. And now I'm going to simplify that negative before I begin to solve. This becomes x plus 1. And then I subtract 1 from both sides. And I find out that x equals 8. You are now going to write it as an ordered pair, because what the solution to this system is, it's the point of intersection. And it is the ordered pair, +8, -1. It's important that when you're doing the solving process, that you're writing neatly and you remember which variable you're solving for first. So example 2, if you notice, it's really not in standard form because remember it's x, y, and a constant. But what I'm looking to see here is that my x's are on top of each other and my y's and my constants, which they are. So I could go ahead and just solve it the way it is. I don't need to put x, y constant, just as long as everything's lined up. And notice this time, my x's have the same number, but this one's -1, this one's +1. So when I go to combine my two equations or add them together, the x's are going to cancel. And then I'm going to add 1y plus 1y, and I get 2y, and then 10 plus 20, and I get 30. I can now divide both sides by 2, and I find that y equals 15. I now need to take my newly found y value, and I need to substitute it back in to either one of the originals. It doesn't matter which. I'm going to substitute it into the second one. The y plus x equals 20. Once I take out y, I replace it with 15. And now I will subtract 15 from both sides. And I find out that x equals 5. So the solution, or the point of intersection of these two equations, is the ordered pair 5, 15. One thing to do if you're ever doing this and you want to check your answer, you can always plug in the ordered pair you found into the two original equations. If it doesn't give you a true statement, then you've done something wrong and you should go back and rework it. If you wanted to get this one in standard form, what you could have done is switch the place of x and y on the first one, and then the same thing here. You got to pull the same sign with it. Really, in this particular problem, since the y's were lined up over each other, and then so were the x's, and so were the constants, I really didn't need to switch the x and the y's places. But if it's not, if they're not lined up, you need to make sure that they're lined up.
So if they switch the 10 with the x, how do we switch that?
Okay, so let's say instead the problem was given to you as y minus 10 equals x. So what we would need to do is move the x to the other side, and you would get -x plus y minus 10 equals 0. And then you would move the 10 back to the other side.
So you just rearrange it?
Yes, by using inverse operations. So if you're moving something across the equal sign, you're using an opposite sign. If it's staying on the same side, you could just reverse the order.
Okay.
So just make sure that if the equations are not given to you with your x's lined up, your y's, and your constants, you will have to do some rearranging. So for example 3, notice this time it's lined up, it's in standard form. However, I'm going to have to multiply both equations in order to get my variable to cancel. So what we're doing here, when we're coming up with a number to multiply by, really what we're doing is finding the least common multiple between 3 and 2, or the least common multiple between 2 and 5. So if I wanted to cancel the x's, I would need to make one of those a positive 6x and the other one a negative 6x. If I wanted to eliminate y, one would need to become a 10y and the other one a negative 10y. I'm going to go ahead, and again, you can choose. It's not set that you have to do x or do y. I'm going to eliminate x. So I'm going to multiply my first equation by negative 2. I'm going to multiply my second equation by positive 3. In doing this, I'm going to get the number in front of x squared to be a positive 6 and a negative 6, and then when I add the equations, they're going to cancel. So let me distribute the 2 to all three parts of the equation. So it becomes negative 6x minus 4y equals negative 8. Then I need to distribute the 3. So 3 times 2x is 6x. 3 times negative 5y is negative 15y. And then 3 times negative 29 is negative 87. Now I can add my two new equations together, and the x term cancels out, becomes a 0. Then I can add negative 4y plus negative 15y and get negative 19y. Then I can add negative 8 plus negative 87 and get negative 95. I now will solve for y by dividing both sides by negative 19, and I get y equals 5. I now take what y equals, and I need to plug it back in to either one of the originals. It doesn't matter which one you choose. So I'm going to go ahead and plug it into the first one. So that equation is 3x plus 2y equals 4. I'm going to replace y with what I just found y to be, which is 5. So 3x plus 2y plus 2 times 5 equals 4. 3x multiply, get 10. Subtract the 10. 3x equals negative 6. Divide by 3. And x equals negative 2. So the solution to this system is the ordered pair 2, 5. Now, when you're doing this, be very careful. Again, label things. When you go to plug it back into the originals, make sure you're substituting it in for the correct variable. If you solve for y, plug it in for y. So just be careful. And my last system, notice my y's have the same number but opposite signs. So I can just go ahead, add them up. So I'm going to add the two equations together. I have a 1 assumed in front of this x, so 1x plus 6x is 7x. The y's have canceled, becomes a 0. And then now you're left with 21 plus 21, which is 42. Divide both sides by 7, and x equals 6. I now take what x equals, and I need to plug it back in to one of the originals. Again, it doesn't matter. I'm going to plug it into the first one. The x minus 5y equals 21. Replace x with 6, because that's what I just found it to be. Subtract 6 now. 21 minus 6 gives me 15. And now I divide both sides by negative 5. And y equals negative 3. So the solution, or the point of intersection of these two equations, is the ordered pair 6, negative 3. Now, I know I did not do any examples of the special cases, but again, if you were to have been given something where the variables canceled and you were left with a true statement, it's all real numbers. Or if the variables cancel and you're left with a false statement, then it's no solution.